Biased sample. A biased sample, or unrepresentative sample, is a logical fallacy where a conclusion about a population is drawn from a sample that is not representative of that population. Because the sample unfairly favors some outcomes over others, the findings of the study are misleading and cannot be reliably generalized to the larger group. This flaw can occur unintentionally due to poor methodology or purposefully to generate misleading results. A sample's lack of representativeness can come from excluding certain groups, overrepresenting others, or not selecting participants randomly. Common types of biased samples. Self-selection, or voluntary response. Bias. This occurs when a study's participants are volunteers. People with strong opinions, either very positive or very negative, are more likely to participate, while those who are apathetic or indifferent tend to be underrepresented. Example. An online poll asks website visitors if they are satisfied with their service. Because only customers with strong feelings will take the time to respond, the results will be skewed and will not reflect the views of the typical customer. Undercoverage bias. This happens when some members of a population are inadequately represented in the sample. Example. A political poll conducted only via landline telephones would have undercoverage bias by systematically excluding younger people and those in lower-income households who are less likely to have a landline. Survivorship bias. The error of only studying the surviving or successful subjects and ignoring those that fell out of view. Example. A financial analyst studies the records of successful, currently operating businesses to understand market trends. The analysis ignores the data from failed companies that no longer exist, leading to an overly optimistic view of the market. Convenience sampling bias. Researchers use a sample that is easy to reach, leading to a non-random, potentially unrepresentative sample. Example. A researcher surveying college students for a freshman project interviews only students in their own class. The sample is not representative of all college students, since they share a common age and field of study. Famous historical examples. 1936 Literary Digest poll. The magazine surveyed its readers, along with registered automobile owners and phone users, and predicted Republican Alf Landon would win the presidential election. The poll was massively biased toward wealthy individuals who were more likely to vote Republican. Franklin D. Roosevelt won the election by a landslide, and the Literary Digest went out of business shortly after. 1948 Dewey defeats Truman headline. The Chicago Tribune ran its infamous headline based on the results of a phone survey conducted weeks before the election. At the time, telephone ownership was still limited, making the survey's sample unrepresentative of the general population. Democrat Harry S. Truman actually won. How to avoid biased sampling. Use simple random sampling. Give every individual in the population an equal chance of being selected for the sample. Use stratified random sampling. Divide the population into subgroups. Strata. And then draw random samples from each subgroup in proportion to its size. Define your target audience. Clearly identify the target population and develop a sampling frame that accurately reflects it. Follow up with non-responders. Try to understand why some individuals are not participating, as their reasons could reveal a non-response bias. Also known as biased statistics, loaded sample, prejudiced statistics, prejudiced sample, loaded statistics, biased induction, biased generalization. Description of biased sample. This fallacy is committed when a person draws a conclusion about a population based on a sample that is biased or prejudiced in some manner. It has the following form. Sample S, which is biased, is taken from population P. Conclusion C is drawn about population P based on S. The person committing the fallacy is misusing the following type of reasoning, which is known variously as inductive generalization, and statistical generalization. X% of all observed A's are B, S. Therefore X% of all A's are B's. The fallacy is committed when the sample of A's is likely to be biased in some manner. A sample is biased or loaded when the method used to take the sample is likely to result in a sample that does not adequately represent the population from which it is drawn. Biased samples are generally not very reliable. As a blatant case, imagine that a person is taking a sample from a truckload of small colored balls, some of which are metal and some of which are plastic. If he used a magnet to select his sample, then his sample would include a disproportionate number of metal balls. After all, the sample will probably be made up entirely of the metal balls. In this case, any conclusions he might draw about the whole population of balls would be unreliable since he would have few or no plastic balls in the sample. The general idea is that biased samples are less likely to contain numbers proportional to the whole population. For example, if a person wants to find out what most Americans thought about gun control, a poll taken at an NRA meeting would be a biased sample. Since the biased sample fallacy is committed when the sample, the observed instances, is biased or loaded, it is important to have samples that are not biased, making a generalization. The best way to do this is to take samples in ways that avoid bias. There are, in general, 3 types of samples that are aimed at avoiding bias. The general idea is that these methods, when used properly, will result in a sample that matches the whole population fairly closely. The 3 types of samples are as follows. Random sample. This is a sample that is taken in such a way that nothing but chance determines which members of the population are selected for the sample. Ideally, any individual member of the population has the same chance as being selected as any other. This type of sample avoids being biased because a biased sample is one that is taken in such a way that some members of the population have a significantly greater chance of being selected for the sample than other members. Unfortunately, creating an ideal random sample is often very difficult. Stratified sample. This is a sample that is taken by using the following steps. 1. The relevant strata, population subgroups, are identified. 2. The number of members in each stratum is determined. And 3. A random sample is taken from each stratum in exact proportion to its size. This method is obviously most useful when dealing with stratified populations. For example, a person's income often influences how she votes. So when conducting a presidential poll, it would be a good idea to take a stratified sample using economic classes as the basis for determining the strata. This method avoids loaded samples by, ideally, ensuring that each stratum of the population is adequately represented. Time-lapse sample. This type of sample is taken by taking a stratified or random sample and then taking at least one more sample with a significant lapse of time between them. After the 2 samples are taken, they can be compared for changes. This method of sample taking is very important when making predictions. A prediction based on only one sample is likely to be a hasty generalization, because the sample is likely to be too small to cover past, present, and future populations. Or a biased sample, because the sample will only include instances from one time period. People often commit biased sample because of bias or prejudice. For example, a person might intentionally or unintentionally seek out people or events that support his bias. As an example, a person who is pushing a particular scientific theory might tend to gather samples that are biased in favor of that theory. People also commonly commit this fallacy because of laziness or sloppiness. It is very easy to simply take a sample from what happens to be easily available rather than taking the time and effort to generate an adequate sample and draw a justified conclusion. It is important to keep in mind that bias is relative to the purpose of the sample. For example, if Bill wanted to know what NRA members thought about a gun control law, then taking a sample to NRA meeting would not be biased. However, if Bill wanted to determine what Americans in general thought about the law, then a sample taken at an NRA meeting would be biased. Examples of biased sample. Bill is assigned by his editor to determine what most Americans think about a new law that will place a federal tax on all modems and computers purchased The revenues from the tax will be used to enforce new online decency laws. Bill, being technically inclined, decides to use an email poll. In his poll, 95% of those surveyed opposed the tax. Bill was quite surprised when 65% of all Americans voted for the taxes. The United Pacifists of America decide to run a poll to determine what Americans think about guns and gun control. Jane is assigned the task of setting up the study. To save mailing costs, she includes the survey form in the group's newsletter mailing. She is very pleased to find out that 95% of those surveyed favor gun control laws, and she tells her friends that the vast majority of Americans favor gun control laws. Large-scale polls were taken in Florida, California, and Maine, and it was found that an average of 55% of those polled spent at least 14 days a year near the ocean. So, it can be safely concluded that 55% of all Americans spend at least 14 days near the ocean each year. 19. Fallacy. Burden of proof. The fallacy of the burden of proof is a logical fallacy where the person making a claim unfairly shifts the responsibility of providing evidence to someone else, demanding that they prove the claim false rather than the claimant proving it true. This fallacy is often committed when someone makes an extraordinary or unfalsifiable claim, asserts it is true, and then refuses to provide evidence, instead challenging the opponent to disprove it. The fundamental principle is that the burden of proof always lies with the person making the positive assertion or claim. How it works. Person 1 makes a claim. Opening parenthesis. E.g. There are tiny, invisible unicorns living in my apartment. Person 2 questions the claim. Opening parenthesis. E.g. How do you know? Closing parenthesis. Person 1 refuses to provide evidence, and instead demands that person 2 prove the claim false. E.g. Can you prove that the unicorns aren't there? Closing parenthesis. Person 1 incorrectly concludes that the claim is true because person 2 cannot provide proof of its falsehood. Examples. I have a unique ability to communicate with aliens, but you can't prove I don't. The person making this claim has the burden to demonstrate their ability, not to have others disprove it. This new energy drink cures all diseases. You can't find a study that says it doesn't. Instead of providing evidence of its effectiveness, the person attempts to shift the responsibility to others to find evidence of its ineffectiveness. Why it's a fallacy. Unfalsifiable claims. This fallacy often involves claims that are impossible to disprove, like the existence of invisible unicorns. Assumption of truth. It relies on the mistaken assumption that a claim is true until proven false. Evasion of responsibility. The core of the fallacy is the evasion of the responsibility to support one's own assertions with evidence. How to respond to it. Point out the fallacy. Explicitly identify that the burden of proof rests on the person making the claim. Demand evidence. Ask them to provide the evidence for their assertion. Reiterate the principle. Emphasize that the lack of evidence against a claim does not make the claim valid. Includes. Appeal to ignorance. Ad ignorantium. Description of burden of proof. Burden of proof is a fallacy in which the burden of proof is placed on the wrong side. Another version occurs when a lack of evidence for side A is taken to be evidence for side B in cases in which the burden of proof actually rests on side B. A common name for this is an appeal to ignorance. This sort of reasoning typically has the following form. Claim X is presented by side A and the burden of proof actually rests on side B. Side B claims that X is false because there is no proof for X. In many situations, one side has the burden of proof resting on it. This side is obligated to provide evidence for its position. The claim of the other side, the one that does not bear the burden of proof, is assumed to be true unless proven otherwise. The difficulty in such cases is determining which side, if any, the burden of proof rests on. In many cases, settling this issue can be a matter of significant debate. In some cases, the burden of proof is set by the situation. For example, in American law a person is assumed to be innocent until proven guilty. Hence the burden of proof is on the prosecution. As another example, in debate the burden of proof is placed on the affirmative team. As a final example, in most cases the burden of proof rests on those who claim something exists, such as Bigfoot, psychic powers, universals, and sense data. Examples of burden of proof. Bill. I think that we should invest more money in expanding the interstate system. Jill. I think that would be a bad idea, considering the state of the treasury. Bill. How can anyone be against highway improvements? Bill. I think that some people have psychic powers. Jill. What is your proof? Bill. No one has been able to prove that people do not have psychic powers. You cannot prove that God does not exist, so he does.